So today we're going to continue with the Python basics about list, dictionaries, and also looping. Any questions before we get started? So make sure you practice. So last week and this week is just about the basic, and you will need to practice a lot because otherwise you move it to actually build your Python packages. So, and next week is the spring break, right? So we don't have classes. And so for this week, I hope we can finish all the Python basics. So we today want to cover here the dictionaries. Conditional statement we already cover, but we need to finish some of the remaining sections in list and then dictionary looping. Then on Thursday, we're going to cover functions, classes, and files and exception. So this we actually are kind of a combinations of all the previous Python basics, but this will be the building blocks for building Python packages. So it's very, very important, and make sure you spend some time read through the notebooks and practice. We're going to have a lot of lab exercise for you to practice this one, and especially if you are beginners, make sure you spend some time to practice. And so first, let me go over here. So we are already, I think, week number 7, and if you look at the schedule, we are still on schedule, but I think we need to move a little bit faster. So here, schedule. So we are on right now here, March 7, and yeah, we should be fine, but make sure you practice. I think that's the most important thing. And let me double check the recording. Okay, everything works fine. So we're going to open the work with list. I think we missed a small section last time. It's about doing slicing. So if you go down to so slicing basically means you take a small sections of the list. We talk about how to do the indexing. Indexing means we're only taking one item. So if you have a list, you just have an item. So the list index starting from 0 all the way to whatever how many number of items in the list minus 1. Okay. So if you have 3 items in the list, the index starts from 0 all the way to what? 3 items. 0, 1, 2. Okay, not 3. And so the slicing means you can take multiple items, including 1 or 2 or 3, whatever how many you want to do. So the slicing in Python is basically separated by colon. Okay, so here we have a list of 1, 2, 3, 4, 5 items. And again, you need to keep in mind the start and the end. So the colon, so you have 2 numbers at the start and the end. So make sure you understand the end is exclusive. Okay, so 0 to 3 basically means I'm going to take a slice of the list. So we'll be start from 0, 1, 2, and then it stops. Okay, it doesn't take 3. So if I run this one, take a look. Charles, Martina, Michael. So the frontends, this one is not included. Okay, so start and the end. So it's pretty simple, just like this. So square brackets and then put inside the index. Similarly, 1 to 4, right? So we'll be starting from here. 1, 2, 3, no 4. Okay, so this ending index is not included in here. And sometimes, so for the start and the end, it's optional, so you don't have to have both. If you only provide the ending index, that means you are starting from the very beginning, okay, to the end. So this will be 0, 1, 2, 3, and then 4 items. So take a look at this one. Essentially, this one skip the last one, the last item. You can also have a start, you don't have an end, so it's going to start from the starting index and all the way to the end. So 0, 1, 2. So you're going to start from Michael and then take all the items from the beginning to the end. So there's another one here. can we skip both of them? Can we do this? Just a colon within the square brackets without doing anything? Can you? So if we don't use the start, it's going to take from the beginning. If you don't provide the end, it's going to take all the way to the end. If you skip both, what it's going to do? Say that again?
I'll say that it just lists all.
Yeah, list of them. It's basically making a copy of the list. So look at this one, it's the same thing. But the nice thing about this is that you're making a copy, so later if you're trying to modify the list, it's remain intact. So this is actually used to copy the item. So you make an exact copy of the list if needed. So similarly for the slicing, you can count from the beginning to the end, or you can count backwards. So you can use negative. Negative means you want to start from the so if I have, for example, here I have -3. What does that mean? So the start is -3, going to be so -1, -2, -3. So it's going to start from here and then all the way to the end. So this is basically going to get the last 3 items from the list. And similarly, you can do, for example, here like -1. So I'm gonna do a slicing and then I skip this one and then I use -1. So what do you think? How many items will be printed out here? What does this really mean? Colon -1, that's it. So how many items left in the list? 4, right? So what does this mean? Basically, -1 means, because if you're counting from -1, -2, right? So -1 is not included. So this essentially is like skip the last one. That's it. So if you want this one, it's going to show you like this. Similarly, I can do -2, -3, whatever you prefer. So this is how you can do the slicing, okay? Start and the end. It need to be integer number, and it can be positive, it can be negative. So it depends on how you want to do that. If you have a long list, if you want to skip some items, you can choose positive or negative, whichever is easier for you. And then you can just do the slicing, or you can just loop through the list. So once you do the slicing, you can think about in Python here, everything is just like a variable. You can do a chain of actions. So you can put things together, or you can assign this one to a variable, and then you just use the variable as a list. Either way is fine. So what this one is doing here, we have a list of 5 items, and then we're going to loop through the. So what does this mean? Players :3. What is this? How many items in this list? :3. How many? First 4. Are you sure? 0, 1, 2. Do you have 3? No. Okay. As I said, ending in this is not included. So it'll be 3 items, and this one essentially is looping the first 3 items, and then put a title case. That's it. Okay. So always keep in mind, start and the end is not included. So if you have 1, you're going to 1 item. You have 2, you have 2 items. 3 items. Right, because it starts from 0, 0, 1, 2, okay? And you can copy a list, exactly the results like what I showed you earlier. If you just put a colon and without doing the start and the index, it's going to basically get the entire content. So basically you're creating a copy of the list. And yeah, I'm going to skip this. The last one I introduced here is tuple, right? So list is wrapped by a square brackets, okay? Tuple is by parentheses, and then there's another one I'm going to introduce later called dictionary. So these all have very different meanings. A list is called mutable. Mutable means you can change the values. So just like what this list in here, right? So for example here, I have this list with 5 items. I print out the first 4. If you want to change the content, it's actually pretty simple. So it will be this variable, and then whatever index you want to index one. So for example 0, and then equal to maybe like what? Maybe Hannah, okay. So I have a list, a variable, define a list, and then I change the first item, for example, to Hannah. So right now, if I print out this variable, what would the value be? The first item. Is it Hannah or Charles? Right, it's being changed. So a list is mutable. Mutable basically means that you can change the content, and sometimes this might have some side effects because you're not, if you're creating something and you don't want the user to change, then it's probably better to use a tuple. Okay, so what does this really mean here? I'm going to do the same thing here. I can say players 2, and so all we need, change the square brackets to parentheses, and take a look at here. Players equal to 2. Now I can do the same thing. Say this, I'm trying to change this one. So players 2, first one, and pay attention. It's going to tell you tuple object does not support item assignment. So what this means that a static is immutable. That means you cannot change. So this in programming sometimes is very important because you want to have some data, you don't want the user to change, then it's better to use this way so that it cannot be changed. Understand? So tuple, immutable. And tuple, you can do the indexing just like this. Everything is pretty much the same. So I can, for example, I can print out the first item, I can print out the second item or the third item, I can do a list indexing. So everything that you can do for list, you can do the same thing for tuple, except that you cannot change it. You can do the indexing, you can do the slicing, that's it. Okay, so tuple is useful for some data that you don't want it to be changed, right? And you can have numbers, you can have items, so the tuple can also be anything. So any data type, you can be a mixed data type. You can have number, you can have strings, you can have object, you can have all kind of stuff in there. And in terms of looping, it's the same like as list. You can for something in something, and then you can start doing all kind of looping in here. So right, so I have 2 numbers, and then I loop through the items. Then you can do whatever within there. You can do a bunch of actions to a dictionary. Okay, so this is for dictionary for tuple and list. And sometimes, for example, you are writing a program and then you are defining a variable that you don't want user to change. But later on, if you want to make some changes to the tuple, one thing you can do is redefine the tuple. So you just assign, for example, here, let's say right now, this is the, for example, this is the tuple we created, right? We have 5 items in there. Now you say that, okay, I want to change it, but if you don't want to go back. So once you can do this, it's pretty simple. I'm going to do this. And I can, for example, I delete this one. Okay. And see here, you can always redefine a variable. So in that way, it's going to override. It's going to override the previous variable. So Python, the name is unique. So if you redefine it, the previous value will be overwritten. So now you see, I can have 4 variables. But if you really want to, I can also convert this one to a list. So now the same thing, if I'm trying to like assign a value to this one, it won't work. Okay, so let me see here. It's going to show you that tuple does not allow the assignment. So one thing you can do here is actually do this way. So I can maybe player number 3 excuse me, equal to, so if you want, you can convert a list to a tuple to a list. So that later on it's changeable, it's mutable. So what you can do here is just the number variable and then equal to list, and then you just put the tuple variable in there. So take a look, you can convert this one to a list. And now if we print out this one, pay attention, right? So now it's square brackets, and here Now I can change this one. See? So I can print this one again. You see, the value will be changed. So in Python, you can convert the data types. Tuple is very restrictive, doesn't want you to change. And if you really want to create a copy of the tuple and then convert to a list and then make changes, you can. So this is certainly something, if you want to, you can do that like this way. Because think about, you are writing a program and you are calling some other packages. Sometimes if the package, the result, for example, a function return a tuple, and you want to make some changes, then you can convert it to a list. Because if you are writing a program from scratch, you know what data type you want. So you can design whatever you want. But if you are building something on top of others, whatever function you are calling, the result being returned, you cannot really control. But you can always convert the data type to something that you can modify. Okay, so this is very common when, especially building a package, you're writing a complicated program. This is something you should pay attention to. Okay. Questions? Right, pretty simple and easy. So next, let's go to list. Dictionary. Sorry. So dictionary is just like in the traditional way of dictionary, right? You have a key, you have the value. That's like you trying to look up a word in the dictionary, and you're trying to look at the meaning. So in programming, we also use dictionary because sometimes if you want to have a data structure and you want to quickly find out all the information related to that one. So think about here, at UT, for example, it maintains a database, but database essentially, you can think about like a dictionary. So you have a unique NAC ID or maybe your social security number. Think about here. And that one is used as the key. And so the value contains all the information about you. Okay. Your GPA, your major, your address, your income, whatever. Everything is contained here. So if it's the university can find your NAC ID, they will find all the information. If they can find your social security number, they can find all the information, right? So everything in the real world is somehow related to a dictionary. Okay, look up things. For example, you try to look up a classroom, right? You're gonna figure out how many buildings, how many chairs, how many computers in there. In the database, there might be unique something pointing to that one. Okay, so dictionary is very important in programming, Python, R, whatever, all kind of languages. They all have the dictionary concept is for you to look up the data. Okay, so as I mentioned, dictionary is wrapped by curly brackets. So in Python, you can have a curly brackets, and within there is going to item, you're going to separate it by comma, and then you want to have a key, have a value, and then separate by colon. So you need to have a pair of key and value separated by comma and then key and value. That's it. Understand? So here I define this one, have a color, and then you can do the indexing. So this is basically the key, and this is. Let me give you another example, maybe easier to understand. So here, look at this one. I will say, okay, I define a dictionary called students. And then within there, I can start defining, for example, your NAC ID. Okay. And then you can have a value, for example, your department. Okay. So look at this one here. I can, for example, I say QWU18. Assume this is where the university store the information about faculty and staff. Okay. And then, so this is the key, is the NAC ID. And then your value can be anything. And keep in mind here, you can just as simple as like faculty. Okay. And then comma. So I can have another one here. I just gonna make something up. I don't know, like maybe Hangzhou, whatever. Like pretend this is another NAC ID. So think about here. I just create a dictionary, and then so within there I have two items, right? Or maybe I have another one here. Maybe Pam, okay, and stuff. Also here within the key, it can be single quotes, it can be double quotes, it doesn't matter. So as long as it's valid, right, you can have single quote, double quotes. So this one here right now, oops, what happened? Oh, I need to have comma. So what? Oh, okay. This is colon. You see, you need to run into all kind of errors. So now we have a dictionary. Technically, it's not called student, maybe called employee. Okay. All right. So I have a dictionary of employees, and then there I have a net. The key are all your net ID, and then your value is basically the content. So with that, now I can start adding the retrieving the content, right? So it'll be employees and then square brackets. So that will be the key. So now say, okay, I want to get information about each one. I just passing your net ID. So the net ID need to be a string or a number. Okay, so I'm going to here use a string says QWU18 and take a look. It's going to get the value. So basically just like look up a word in the dictionary. I get the key, then I can get the value. Okay. So similarly, I can change to another one. For example, ham. You're gonna get the value. So you have to keep in mind. Right now, I just simply put in a text, but this item can be anything. It can be another dictionary. For example, I can have like your name, and then within there, you're gonna your address, your value, your real address, and your major, your department, right? It can be nested. So it's very common in Python. You're going to find some nested stuff, right? So this is the simplest one, and you can certainly make changes. So here, for example, employee, you can get the value. You can make changes. For example, okay, this is wrong. I'm going to change this one to a student, right? And once you run this one, if you type employee, see, just like a list, you can make changes to the content. So this is the key and the values. So you can also like get all the keys all at once. You can also get all the values all at once. Just like the university, for example, right now trying to figure out, right? You have all the net ID. I want to figure out like how many net IDs, how many students in the university, how many students in the university, how many faculty, right? You can also do it easily. So the function is the same, like a len, L-E-N. So here will be employees. Take a look, 3, right? And if you add a new, for example, right now this is what we have, and they said in the fall 2023 we have new student coming. It's going to just add those students into the database. So here I can add another one. For example, if the key already exists, you're going to replace the value. If that one doesn't exist yet, it's going to create the new key. So here I can maybe add a new one here. Okay, look, student. And now if you type this one, employee, you see, I'm gonna get 4. So you can push content. And they say, okay, somebody already graduated. You remove it from the list or move it to another dictionary, right? So we can also do the same thing here. What you can do is delete something from there. You can either use pop or you can use delete. So it will simply just DL and then employee. Okay, let's say already, okay, Natu already graduated. So I'm just going to SAN2, just DL. And now if I run this one again, you see it's gone. So basically you can add items to the list, remove item, add the dictionary, you can remove it, you can add new contents. And this is a very efficient data structure, because just like you look up a word in the dictionary, if you know the first character, you're just going to skip directly to the character starting with that character, right? But if it is a list, then you have to go one by one. It's going to take time. So this is more efficient for looking up information, because Python know how to quickly locate the item. So it's a lot more efficient for looking up data. And so this is how you add an item, delete an item, and then you can also, like, for example, get all the values. So you'll be like just like this. Employees dot, you just hit dot, and then you're going to show you some of the available functionality for this one. So for example, clear, right? You can probably know that it's going to clear the entire dictionary. It's going to return as an empty one. Or you can copy, you can get, you can have items, you can have keys, you can have pop, you can update, you can also have values. So the common one will be keys, right? Let's say I want to get all the net IDs all at once, right? So you'll be the keys and then parentheses, because all of them are functions. So you need to make sure that you have parentheses. If I run this one, you see here, dictionary.keys, and then this one, right? So similarly, if you want to get all the values all at once, let's say you want to get, like, for example, you want to do a summary, see how many this is the dictionary, right? You have a bunch of these, and then you have different type, faculty, students, staff. You want to figure out like how many faculties in there, how many students. Then in that case, you don't really care about the name. You don't care about the net ID. You care about that column, the value, right? So you can do the same thing. You'll be values. You're going to get all the values all at once. Okay, so this is another way. Also, you can get items. Item means you can get like pair, key value, key value, key value. So you'll be items like this. So it's also going to return it as a list. This is useful because sometimes you need to loop through the items, and then you want to use the key, you want to use the value, so the items would be also useful. Okay, so this is how you can make changes, grab the information. And the other thing would be trying to make changes to all the items in the list. So let me show you, for example, this is the one that we have right now, all the employees. And they say, okay, right now they are all lowercase. I want to change it to title case, right? So this is the dictionary. This is where programming can help you, because all you need to do is to loop through items and then just make changes all at once. Understand? So think about here, how do we use a looping to make changes to all the content, right? So basically I'm looping through the dictionary, and then each time you grab the value, I'm going to change that value to title case. Think about that. How are we going to do that? Anyone? Any proposals? How do we make changes? How do we change, for example, faculty to title case, F uppercase, right? Student, staff, right? Can you do that? How are we going to do that? So earlier I already showed you how to modify an item like individually, but now I'm going to do that for all of them. Anyone? You can loop through the key, you can loop through the value. So probably the easiest one will just loop through the keys. So let me show you how we're going to do that. So I would say for employee in employees, okay? And you can just directly use this way. By default, it's going to loop through the key, or you can just also like, oops, for employee in employee stock keys. Either one is fine. It doesn't really matter. So here, this is where you can make changes. So I'm going to modify the content and then change it to uppercase. So what you can do here, you'll be employees, right? So you are indexing the key. Right now, this employee actually is the key. And so it'll be square brackets, employees equal to, it's the same thing, right? You have the value, I'm going to change it to uppercase. So you overwrite the content. So look at this one, you'll be like this. Dot title. That's it. As simple as that. So I'm looping through the dictionary. I'm looping through the key. And I grab the key, because you have the key, you can access the value, right? So it'll be your variable, square brackets, your key. And then the content, you can do whatever you want. I grab the original content and then change to uppercase. So take a look. And then now if I print out, boom, right? All done. You can do all kinds of things. So this is just a simple example that you can change the content, but it doesn't have to. So it can also be as simple as this one. So you don't really, if you're looping through the dictionary, you are looping through the key. I don't actually have to use the dot keys. By default, it's going to loop through, and then it's going to use the key to loop through. So this will be the same result. So I'm going to run this one. You see, it's exactly the same. Or you can also just loop through the value. So I can say employees.values, and then this one, it doesn't really work here anymore. So I can just print out, probably it's not good to use this one. It may be just like value for value in employees.values, and then can just print out value, right? So you can also loop through the value. And the other one is you can actually loop through the items. So in that way, you can get the key and the value all at once. So you'll be like this, for key value, comma, in employees dot items. So think about this for a second, right? Items, that means you're going to grab each item, and then each item going to have a key, have a value. So here, if you do it this way, you can also have a parentheses if you want to make it like readable, just like you here, right? Look at this one. So you have a list, you have a tuple, you have a key and a value. So earlier when we're trying to change the value, this can do the same thing. So you'll be here, you'll be employees square brackets key equal to, because once you have the key, you can get the value. So you'll be just like this. So you'll be employee. Originally you can do it this way. You'll be value dot title. Okay, as simple as that. The same thing, just like what we did earlier, right? So we are looping through the dictionary, and then for each one we're gonna get the key and the value, right? So this is the variable. If you access the key, basically you are getting the value, and this is the original value. You just use the title case, then it's going to change it to title case. So if you run this one again, take a look, same thing. So there are multiple ways you can loop through a dictionary, and this is super important. So make sure that you practice, you know, what kind of things you can do to a dictionary. So you can do the looping by the key, you can do the looping by the values, you can do the looping by the items, and then so within there, in between, you can do all kind of stuff. So now, for example, here, they say, okay, I have this dictionary, I want to change it to add UTK to all of them. So UTK faculty, UTK student, UTK staff, because they might be like UT Martin or UT other like campuses. So I want to add UTK, your campus at the beginning of this one. So how should we do that? Can we? How do we add UTK to the beginning of the value? What things do we need to do here? Anyone? Is that difficult? Right, add UTK. How do you add UTK? So always think about here. If you can do that for one, you can do that for all of them. It's that simple. Python is just basically looping, right? So how do you add UTK to a string at the beginning? Just UTK, right? Plus. That's it. It should be pretty simple. So what you need to do here is just like this. UTK plus, right? So plus means you can join a string. Oh, you need to add a space. So maybe add a space. Oops. Add a space here. Oops. Imp. P-A-O-Y. What? Uppercase, lowercase. Right? That's simple. Oh, why do I have all? Because earlier I run that multiple times. So if I run this one again, now you should have UTK faculty, UTK student, UTK staff. Alright, so think about the logic. Anytime if you're trying to do something to a list, to a dictionary, to an item, think about how do I do that for one item? Because when you figure out, then the next will be just do a looping. And within the loop, just do something, that's it, right? So this is how we can utilize a dictionary, and yeah, this is pretty simple and straightforward. So you can have a key, you have a value, and then you can make changes. So you can also, when you create a dictionary, you can also do it like this way. I can just create an employee, right, equal to, it can be an empty square bracket, curly brackets. That means you are creating an empty dictionary. Once you have that, you can use the key value, you can add new information into the list. So it'll be, for example, employees, and then so here I will be saying QW. Oops, what is this? You'll be this one, and then here I'll say QWU, okay, equal to faculty. All right, and now you can just print out. So you can create an empty one and then you can assign values later on, or you can create one and then pass in all the values you want to have initially. So it just like a list, you can define a empty square brackets if you want to. So this is how you can create the list, and then you can start with empty list. You can modify the value, something like that. So it's pretty simple and straightforward. You can remove that. So DL, that means you can delete it, or you can use the pop. Okay, the pop function is the same. The difference is that when you delete something, it's gone forever. But sometimes if you want to do something before you delete something, for example, they say, okay, you are graduating, I'm removing you from the list of the current students. Then probably before I delete everything, I probably want to do something to this. For example, I want to get your employer or whatever, and then put you into another list. So in that way, it's better to use pop. So pop means I can get the value and I can do something to that value. So basically you keep the content, but it's getting out before you remove it from the memory. And look through the dictionary here, right? By key, by value, you can do it by items, blah, 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 right? So here, for example, run this one. I have all the name, your favorite languages, and then I'm going to look through and we're going to change the name to title case. Pretty much very similar. If you want to, for example, loop through that alphabetically, then you can do it this way, like sort. So the sorted function can be used to sort a list. It can also be used to sort a dictionary, right? Because when you think about here, when you define the dictionary, it might not necessarily be alphabetical order, okay? So whenever you create the list, it's going to loop through as a dictionary. So, but in the reality in a dictionary, you're going to start from A, B, C, D, E, F, G, right? But for you don't have to do that. Python will smart enough to be able to figure out how to grab that item. But when you're looping through that, it's based on the sequence that it was created. So if I'm looping through this item, you're going to loop through this one, this one, this one, this one. So it's not necessarily in alphabetical order. If you really want to do that, you can do the sorting. So you can sort the dictionary, and then it will become something like this. So you're going to sort the keys. Basically, you're going to sort the keys, and then you just loop through the keys, right? So in this way, I'm sorting these 4 keys, and then do the sorting function, and then when it's printed out, you see here starting from E, J, P, H. Understand? So it doesn't really sort the dictionary. You are basically grabbing all the keys and then reswap all the keys to make in a alphabetical order, and then use the key and then grab the value from there, get the second key, grab the value from there. So actually this one does not modify the dictionary. The dictionary can be presented in whatever way, but I'm also just getting the key modified, getting the content, and that's it. So you can also loop through all the values just like here, and the next one here, this is more interesting. So this is called nested structure. As I mentioned earlier, you can have a dictionary of dictionary of dictionary of dictionary, or you can have a dictionary of list of dictionary. So it can get quite complicated. So let me go back to this example that I showed you earlier. Like, how do you actually do a nested list? Where is it? Where did you miss? Did I delete it? Oh, here. Let me go back to this one here. Okay. So employee, right? So earlier, it's pretty simple. I just have a faculty, but you can do a bunch of things in there. So you can have the value, the key must be string or a number, but the value can be anything. It can be an object, it can be a number, it can be a string, you can pretty much anything. So here, let me do it this way here. I'm going to have a curly brackets. Okay. So within there, for example, I'm going to get the next ID, and then from there, I'm going to populate a bunch of information. So I can, for example, here, I can say your name and then comma. Okay. So I'm going to write my name here. And then I can have, it's a dictionary, right? Separated by colon. And then I can have more information in there. I can have another one, for example, let's say type. Okay. Colon. And say faculty. Okay. And you can also have your major, for example, your department. Okay. Colon. And then geography. Okay. You can add as many information you like, right? So you have a name, type, department, and maybe age, for example. Okay, 18. Okay, so now you see I can have this, and also keep in mind a dictionary doesn't have to be the same structure, so the value can be mixed. So here I can have a dictionary, I can have a string, I can have a number. Here it doesn't really matter. So it does not have to be standardized, but usually it will be, because this will be useful if you're trying to look through the items, right? So now take a look at this one. I just define this one here, and then employees. You see? So this one here has a lot of information. So for now, if I really want to access the information, for example, I want to figure out what department of that faculty. Okay, so here it will be employees, and they say I'm going to try to find out GEOG-510, right? So this is where you can do the indexing, so get the information that you need. So first I grab this one, and how do I go to the next step? How do I find out what department I'm in, right? So I grab this one right now, the value, you return a value. The value is a dictionary, right? So how do I get a value from the dictionary, right? You need the key again. So here you'll be another square bracket key, so you can continue. So you here will be department. Now you get to the department. So you can, basically this is a nested structure, so you can go deeper and deeper. And from here, also make sure that the key exists, because if the key doesn't exist, you're going to get error. So take a look at this one, right? This one here, I have the value on here, but for the second one, it doesn't have. For this one, doesn't have, right? So if I change this one to, for example, PAM, run this one, it's going to tell you string indices must be integers. Basically, it doesn't exist, so you cannot get the value. And it's good to basically standardize all of them, and then so they can loop through them to get the same way information, right? So this is so-called the nested list. You can also have a nested dictionary. You can also have a list. I can also do it like this way. Let me show you here. I can say here, name was Hannah, whatever. Okay, and then I can do a comma. I can say forestry. Okay. Okay. And then, let me see here, add students. And then I can do this one. Alright, 16. It should work as well. So, but you have to keep in mind, because right now, the value here, this is a list. It's not a dictionary anymore. So you cannot actually use the key to access the value, but you can use the indexing, right? So here you'll be getting, for example, you can get 1, 2, right? So if you're gonna, for example, the department, so it'll be 0, 1, 2. So what you can do is just put 2 in here. You can get the value, but this is usually not recommended, because a dictionary you want to use the same structure. So in that way you can do the looping. It will make your life much easier. But you can be nested. What I'm saying here, you can nest it. So here, for example, this the last one here. Let me see. I want to add an address. Okay, so it can be address, and then colon again. So keep in mind here, I can have another dictionary. Okay, so here I will be, for example, street, and then I can say 1000. Read it. Email way. Okay, so the street, and then I have another one here, city. Okay, Knoxville. State, TN, and then comma. I can also zip code 37996. Okay, so now let me give you a task. How do I figure out the zip code? How do I figure out my zip code? So how do I get access to the zip code information? Right? Don't read. Don't like 37996. Not the point. You need to ask the right program to get that value programmatically. Can you? Right? So simple as that. It's just step by step. If you can get the content, if you go to the next one, right? So for the first one here, you'll be like this, right? QWU18. Get it? You already get the information. What's the next step? How do I get the zip code? What's the next step? Square brackets? Or address? Right? Oops. And then? What's the next step? Another square bracket? Yeah. Zip. That's it. So this is how you go like step by step. You can get to the information. So because it's a nested structure, you need to know like where to get it. Just like you're trying, for example, right now you're the president of the university. You're trying to figure out, for example, how many students in that department, or how many computers, for example, in this classroom, right? So you need to get to, for example, the building, and then the room number, and then get into the room, and then like see how many like computers in the classroom. So you get to step one level by one level. Eventually, you're going to get to the information that you need. So this is about the nested structure, and again, you can you're welcome to practice. And also you can use the get function. So earlier we used the index and the key. So if I go back to this example here, right? And so employee and address. So we use the uppercase zip in here. But if I use the lowercase, also keep in mind it's case sensitive. So if the dictionary has the key uppercase, then you have to use uppercase. So if I change to lowercase, it's going to throw an error, right? One thing you can do here the best practice is to actually use the get function. So the get function means if the key doesn't exist, you're going to return none. So basically, if you're designing a program, you don't want to like when user like run your program to get something like this. This is not robust. So use it like this. Use .get, and then use the zip. So here, you see, there's no error, but it doesn't return anything. The reason for that is this zip doesn't exist. So if they exist, it's going to get you the value. If it doesn't exist, it's going to be empty. So basically just return as none. So if you want to check, you can say get this value is none. It says true because it's none, because it doesn't return anything. So the get function allows you to by default, because if you're writing a program, the user can enter anything. So for example, they're trying to search your NAC ID. If your NAC ID doesn't exist in the database, you're going to run, you can either throw an error, or you can tell the user that okay, doesn't exist. So here, I can do it this way. For example, oops, employees. So do the same thing here. Let me show you an example, right? Employee, and then I'm going to get this user, okay? Exists. If it doesn't exist, for example, I can say PAMM, okay? Doesn't exist. It's this throwing error. But the better way to handle this would be .get, and then parentheses. And then like this, oops, comma. By default, if it doesn't exist, it's going to be none. But the nice thing about the get function is that allows you to set a default value. So basically, if it doesn't exist, you can print out something, or you can get the default username or something here. So it will be comma, and then you can just write this user does not exist. So pay attention. See, so basically allows you to set a default value, so that in that way you can, if the something doesn't exist, you can give a warning message, or you can print out something rather than throw an error. Okay, so this is the better way to handle this. Of course, you can like do it this way here, right? PAMM, right? which way do you prefer? Right, probably the first one. Okay, so the get function is useful in this case when the user is trying to access something that doesn't exist. So if you're writing the program, you want to make it robust, and for example, you are creating a website and you want to allow users to log in into your website. If the user account doesn't exist yet, you can basically ask them, oh, this account doesn't exist, please create an account, rather than like crash your website. Okay, so that's the difference that you're going to design something. And so loop through the dictionary, nested structure depends on the order, or a list of dictionary, or a dictionary of lists, right? So it can be quite complicated. You can have something like pretty complicated. So here we have like a user and a dictionary of dictionary, dictionary of dictionary, or you can also convert to a list. So it's very common. So in the real world, the data type sometimes can be quite complicated. Depends on how you want to access the information, how you want to store the information. So all the data structure in Python eventually comes from this basic data type. It's a combination, it's a composition of a simple data type into a complicated one. So at the end of the day, it's called object-oriented language. We'll get into more about later, like how you create something, how you define something. So then later when the user is trying to create, for example, create a map, right? A leaf map, and then parentheses. Where does that actually come from? It's built on top of another map, and then you have another class, and then another class. So you can actually inherit, build on top what other people have developed, rather than start from scratch. Okay, so that's about the dictionary. And the next one, any questions before we move to the next one? So the next one is about looping. We have covered the looping about the so-called for loop. But Python has another one called while loop. While loop, for loop means you already know how many people in there, how many items in the list, so they can for something in something. But sometimes you have no idea how many in there. Then in this case, the while loop, it will be useful. Just like, for example, you're having you are organizing an event, and you want to give everyone that come to the event a gift, right? So, but you have no idea how many people are coming. And in Python, if you need to do something to everyone, then in this case, it's going to be a while loop. So the while loop, basically, it doesn't care how many in there, as long as you meet the condition. As long as you, like, for example, right now here in this classroom, we have total of 16, but I don't know how many you are in there. Now I'm trying to like ask you to each of you to do something. In that way, I cannot use the for loop because I don't know how many students are in class. But I can use a while loop and then do each item, and then until the list is empty, then I can stop the condition. So this is called doing here, just like in this case, a while loop, right? So I can start a number, and then each time if the number, so this is the condition, so this is called the stop condition, while something meet the condition. So if the current number less than 5, I'm going to print out the number, and then I'm going to increase the number by 1. So this is similar to the debugging that I showed you last time. You can actually do debugging. So I think it's easier for you to actually use this one in Visual Studio Code. So looping is very important, especially if a beginner, you don't know like actually how the program is running. So this is where the debugging is very helpful. It's going to tell you exactly how the program is running through the looping. So again, I'm going to create a new Python file here, and maybe I'm just going to make while.py, right? And then, oh, where is it? Not sure what's okay, it's done. And then let me paste this one here. This is a very simple program, right? What count number equal to this one, and let's run it just to show you like the output first, and then we can start doing the looping. So we can go through that just to see how the program is running through. So I'm going to run this one. Oops. I need to change select interpreter GEOS, and then run again. So look at the bottom here. It's going to print out the result. Okay. Oops, what happened? Okay, print out. It's a bit slow, but you see here 1, 2, 3, 4, 5. Right? So here, this is the number, and then the while loop basically while condition, and then within the condition you can do whatever you want. So what we are doing here is, okay, if the number is less than 5, I'm going to print out the number, and then plus equal 1 means basically current number equal to current number plus 1. So this is basically the shortcut. And so the first time is 1, and it's going to print out 1, and then it's going to add 1 to 1, it becomes 2. Then it's going to come back to the while loop. Is 2 less than equal than 5? Yes. Then print out 2, and then 2 becomes 3, 3 less than 5, and then print out 3. So basically on and on. So this is where if you want to do the debugging to see how the program is running, you press a breakpoint. So if you click on the left side here, you add a breakpoint, and then you can say start debugging. And just like what we did last time using the for loop, this is useful to figure out how the program is looping through the information. So now it stops here, and look at the left side. The variables, nothing in there here yet. So just run this one, step into. Okay. So on the left side here, now you see the current number is 1. Okay. Then it's going to go through the looping. So this is called while loop. It doesn't care how many items in there because I don't have to know. Okay. And then step into, print out the current number. At the bottom here, it's going to print out 1. And then pay attention to the left side here, because you need to have a stop condition. Otherwise, you're going to have a so-called indefinite loop. It's going to run forever. Just like you are using Windows, sometimes you cannot stop the program because it's running like forever. So here, if I click this one, you see current number becomes 2, and see the cursor like bouncing back to this line here, and then run this one, number becomes 3, and then come back, run this one, and now what's number 4, right? So here, and pay attention, nice, number 4, and we'll come back here again. So now the number is 5. It's going to compare this number. Is number less equal than 5? Yes. Run through, and now the number becomes 6. See here, it come back to here. Now you check the condition again. It doesn't meet the condition anymore. So if I run this one again, it's going to stop. Okay, so take a look. It's done. So the stop condition is very, very important. But of course, here I can just change to anything. I can just maybe change to 10. That means it's going to print out the number from 1 to 10, right? So I can run, start without debugging. It's going to run all through that. So if you don't know like how Python is running the code, just try to use this debugging. It's going to help you think through how it's actually make changes to the variable and how is it looping through the variable, right? So 1 to 10, just like this. So you can write a while loop. And in this case, I don't really have to know like how many numbers in there, because maybe let me run you another one. So for example, equal to 1, and then each time I want to like increase by 3. So think about it for a second, maybe like to 100. Okay, give you 2 seconds. Tell me how many numbers will be printed out. Right, hard to tell, right? You have to think about it, how you calculate. This is where the while loop is useful. I don't care how many items in there. I just use the while loop. But if you try to use a for loop, now for number in this list, you need to have the list. You need to have all the numbers. But in this case, I don't really have. I just going to each time I loop through the number, increase by 3, and then it's going to run through until it close to 100, and then you exit the loop, right? So this will be definitely, this is the case that will be useful because I don't have to worry about how many in there. I don't use the for loop. So for loop is not a good user case in this example because you have to know, you need to have all the numbers first, right? And then so I can just run continue. You see 1, 4, 7. I don't need to count. I don't care. But if you really want to, you can do the same thing. It will be like this. So let me show you here. If you want to do it the other way, it will be 4, I in range, okay, it's pretty smart. I don't need to write. So start from 1 to 101, each time increase by 3. You can do it this way if you want to, but again, you need to have all the numbers. So now if I run this one without debugging, you should get all the numbers all at once. Right, one list and then go to another list. The results should be the same. Okay, but this is like the while loop. The beauty of using the while loop is I don't care about how many items in there. I just set up the condition, and then once the condition meets, then I can stop. So always make sure that you start a condition that's like useful. Otherwise, it's going to run forever. Okay, so pay attention to this one, right? Current number equal to 1, and then if the number, let's say, greater than 1. So think about this for a second. Is this a valid loop? So the number is equal to 1, and then you're going to come to this condition, greater than 1. Is it? So what kind of output you're going to see? Are you going to see any outputs? So 1, is 1 greater than 1? Yes or no? 1 greater than 1? No. No, that means it doesn't actually run anything because the condition. So you need to design something that at least you can meet some of the conditions. Right now it's going to be empty. It's not going to show you anything because there's no condition. But think of the magic here. If I change to this one, what will happen? What will happen here? Is it 1 greater or equal than 1? Yes? Right? It's going to run one time, and then it's going to increase by 3, becomes 4. 4 greater or equal than 1? Yes? Will it ever stop? Will it stop? Let's run this one again. And this is, you need to be very careful. Sometimes you can design a program that's like has a loop, indefinite loop here. It's going to crash the user's computer. Okay, it's going to take some time to run, and okay, that means just once do it. Pay attention. See here? It will never stop. Alright. So now because I'm doing debugging, I can just close it. If I'm not doing debugging, your program, you need to shut down. You need to force it shut down, because this is what happens if you're trying to do something like in here. Oops. Not good. This is just like hackers showing something on the screen. You can design programs just like to run this one on the screen and then pretend that you are a hacker. Okay, so I'm going to stop this one. You see, not good. You are not going to design a program like this. So there's a one way they can do, like an easy way to stop this. Okay, so that means when something exists, something, you can have a so-called break condition. So break means I'm done with this one. I'm done with the loop. So what you can do here, you'll be print up. You can add another one here. If current number, okay, greater than 100 colon break. So what does this mean is that this is usually not a good way. I mean, if you can like greater equal than 1, of course you're going to check this condition, but also you can have another condition inside. So if you get the number 1, 4, 7, and then so all the way, if the number is greater than 100, it's going to break. Break, it means you are breaking out of this loop. Okay, so now if I run this one again, pay attention to see how many in there. So this is how you can either provide the conditions. Ideally, you should put the condition in here rather than in here, but sometimes you don't know, but you just want to break out here, right? Take a look. Now it doesn't do it, but you should basically do it in here. You should do it like less or equal than 100, and then so in this way you don't need the break function. Okay, so here I then run this one again. That means you're going to do the same thing. So from 1, 4 all the way to 100. And there's another one called continue. Continue means you skip you skip this one, you don't do anything. Okay, so think about here for a second. I have this number. For example, if the number can be divided by 3, then I print out this one. Otherwise, maybe do it this way here, else, and then print. Okay, you win. Okay, so inside here, you can do different things. So within the looping, so you can provide whatever condition you want to run. So if a number is a multiple of 3, you can print out something rather than print out the number, and then otherwise you print the number. So if I run this one again, one without debugging. Okay. Whoops. Is it one? Oop. Oh, there's no number like you can divide it by 3. Maybe 5 would be better. Okay, you see here, you win, right? So within the loop, basically you can do all kind of things you want to. All right, so this is about doing the looping. Also, why I have this one here. Actions, you can use a flag, you can exit the loops. I comment out a lot of codes in here because I mean when it's building the website, it's going to run from beginning to the end. If there's an error, it's going to throw out an error. And lastly, I'm going to introduce the function called input. So input is a function that's for users to enter something. So you can provide input. So let me comment out this one here. This is called input function, and this is basically the prompt. Just like you are creating a website, you want to allow the user to create a username, just like the password. For example, you're trying to create a Gmail on Google, right? You can design a program, allow the user to enter information, and then you change. Now based on the user input, then you can provide some conditions. So here, take a look at this one, right? A number, and then input equal to something. So it's gonna ask you, okay, enter number. I will tell you either it's an even number or odd number. So here, your program basically is running this one here, and for example, I just enter 10, and then hit enter. You will see the number 10 is even, and I need to run again. Oops, what happened? Invalid syntax. Okay, let me run this one again. Right now you have pressed 9. It's an odd number, right? So here you can think about this program only run once, and then your program stops. Right? Can you design a program that allow the user to continuously enter a number and then give you whether it's an odd number or even number, but when the user enter quick, then you quit the program? Understand? Can you do that? So think about here. Before you do that, don't worry about like how to quit. You design this program first. This is basically you can do that once, and then you put that inside a loop, because the while loop is useful in this case. You don't know like how many times the user want to run your program, but you can use the while loop and then to have a stop condition. So this way, but you need to figure out the stop condition. So you can give the user instruction. For example, if you enter quit, I'm going to quit this program. So this is where it's going to be magic. Okay. So I'm going to here, I'm going to while, very simple, it's a while true. While true is going to run forever, because true is always going to be true, right? But within it, I can have a stop condition. So this is where it's going to be useful. So all you need, put everything within the loop. But you need to have the stop condition. Otherwise, this is going to run forever. It's never going to stop. Just like you sometimes open a program on Windows, you need to keep like close, it's never ending. But what I can do here is I can do it here. Let me show you what you can do. So it allows the user to enter number, but if the user enters something like quick, then you quit the program. So what you can do here will be if number equal to quit and then colon break. As simple as that. In this way, the program will run continuously until the user enter quick, and then it's going to done. So take a look. Okay, tell me a number whether it's odd or even. 1, 2, right? And then I'm done. Quit. Boom. See how simple it is, right? So if you want to design something that want to run a program, whatever, this will be the input, and also the while loop is very powerful, because I don't care how many times you want to run my program, as long as if you want to stop, if I provide the stop condition. If you don't provide this one, if you don't have this one, it's going to run forever. Then Jupyter Notebook is going to crash, and not crash, it's never going to stop. Then you have to force to do that. So this will be useful. For example, here, you can either, right, if I run this one here, you're going to throw an error, and this is where we're going to cover in Notebook 10, basically trial error. So handle the exception. If the user enters something invalid, you should also maybe just skip and then continue. So in this way, it will run forever. So this will be something like this. For example, here, let me show you how you can design this one. So all we need to just put this in the try except block. We haven't covered this yet, but I just want to give an example so they can quickly accept. And then I can say continue. So let's try this one here. Oops. You see? It doesn't care, it just skip, it just continue. So now the program doesn't run slow into any error. Oops. If I give you a number, right? It's going to tell you it's odd number, even number. If I press any string, it's going to just continue. So continue means I don't care. I don't need to run the next one. It's going to go back to the while loop. Okay. The break means I'm going to break. So the last one here, let me quit. See? So this is how you can design programs. So think about your package. At the end, you want to define some functionalities. You want to accept a user input if you want to. And then you can, behind under the hood, you can design functions to deal with the situation. And then based on the user inputs, you can do all kinds of things. Okay, so that's all about the user input. You're welcome to go through it. Some of those examples might be a little bit complicated, but make sure you run that at least once. Don't just read, okay? Program is not learned by reading, okay? Unless you read it at a high level, you can understand. Otherwise, it's better just practice. And then if you have any issues with the code, if you don't anything you don't understand, copy the code, put it into Visual Studio Code, and then start debugging. Add a breakpoint, and then in that way you can know how the program is running line by line. You will have a much better understanding the logic. And once you have enough practice, then you can just read. I don't have to practice. I know in my mind how the program is executing. Okay, so that's all for today. And so for Thursday, we're gonna cover the last three, and that's pretty much about condensed introduction to the Python basics. And starting after the spring break, then we're going to get into the real building Python package for geospatial applications. Okay, so thank you very much, and I will see you on Thursday.
Dr. Wu?
Yes?
Would there be a study guide for